Welcome to class, folks. Your video today is about
Arithmetic series.
And your learning target is I can find the sum of a finite arithmetic series using the formula. So we're going to have a new formula in this lesson. And so here comes the lesson. And you want to take a look at Yoda? Here's Yoda. There's Yoda. Okay, here we go. So if we're going to talk about a series, we need to know the definition of a series. Now, we know that an arithmetic sequence is a list of numbers that follow an arithmetic pattern with a common difference. Well, a series is the indicated sum of the terms of an arithmetic sequence. So, a series is the indicated sum of the terms of a sequence. Did you know Yoda uses a green lightsaber? Yeah, he does. So we've got these two different kinds of series that we're going to talk about. We've got a finite series and an infinite series. Specifically, the standards for your Algebra 2 EOC exam are going to ask us to focus in on these finite series. We don't really have to do so much with the infinite series, but we will talk about the difference. So a finite series has a first term and a last term. Isn't that great effect? Okay, an infinite series continues without an end. So it goes on and on and on forever. So for example, here is a finite series example. May the force be with you. Where in a finite series example, we start with a specific number, we end with a specific number, and since we know the beginning and end, we can find the specific sum. So if you add up 6 plus 9 plus 12 plus 15 plus 18, which we know this is the arithmetic sequence with a common difference of 3, we're increasing by 3 each time. If we add up that list of numbers, the sum would be 60. If we look at this infinite series example, right here, infinite series example, we can't really add up the list with 3 plus 7 plus 11 plus 15 plus ongoing. An infinite series goes on and on forever. I can't add up the list because I don't know what the ending point is or the ending number. So, finding the sum of an infinite series, we can't really get a specific number sum. And we are specifically asked to find sums of finite series for our end of course exam. So we're going to zone in on that. So, of course, we're going to have a formula for an arithmetic series. Finding the sum of a finite series, our formula is Sn equals n over 2 times the sum of a1 plus an. Well, we need to talk about what these little parts are. A1, specifically, we know what that is already. That's the first term that we're adding up in our series. An is whatever the last term is that we are adding up. Not last term, last term. Okay, and N represents how many numbers are in this list that we are adding up. So it's the number of terms that we're adding up. Sn, of course, just represents the sum of n terms. So n represents how many terms we're adding up. Sn is the sum of n terms. A1 is going to be your first term, and an is the last number you're adding. So let's look at an application of this. Find the sum of each finite arithmetic series. So if the first term is 12, and the nth term, or the last term we're going to add up, is 100, and we're going to add up 12 numbers, what's the sum of those 12 numbers that we're adding up? So let's begin with the formula. So, according to the formula, Sn is equal to n over 2 times a1 plus an. I'm going to replace n with 12. So I'm going to find the sum of 12 numbers. So n gets replaced with 12. Where the first number in my list that I'm adding is the number 12, and the last number in the list that I'm adding is the number 100. So, this is something that can go straight into the calculator. Calculator is smart enough to handle it, but let's think through it a little bit. 12 divided by 2 is 6, and 12 plus 100 is 112. So really, we're going to multiply 6 times 112 to get our sum. So that sum is 672. So the sum of those 12 numbers in this finite arithmetic series is 672. The next example is a little bit trickier. It says to find the sum, so I'm going to start with my sum formula. Sn equals n over 2 times a1 plus an. It tells me that I'm finding the sum of 28 terms, so that's going to be S28. So I'm adding up 28 numbers. And my first term is 42. But it does not tell me what my last number is. It does not give me the value for an. I don't know an. It doesn't tell me up here. But what does it give me? It tells me the common difference. So what I need to do now is say, is there a way I can figure out what the last number is in this series if I know the common difference is 6 and the first term is 42 and I'm adding up 28 numbers? And the way we're going to do that is we're going to divert back to the formula that we studied last week, the arithmetic sequence formula. So going back to the arithmetic sequence formula, if A1 is the number 42, and we're talking about the 28th term, we can find the 28th term, which is our AN, because we know that the common difference is 6. So we can evaluate A28, which in this case will be our AN. Our AN is the 28th term because N was 28, by using the arithmetic sequence formula. So that 28th term is actually the number 204. And once I know that A28 is 204, I know that that is the number I needed for AN. So now I can say, okay, AN was 204. Now I can find the sum of those numbers. So AN was a missing piece that I needed. And I had to go find it using this arithmetic sequence formula. So now that I have all the pieces I need in the arithmetic series formula, I can simplify that. So the sum of those 28 numbers, 28 divided by 2 would be 14, and 204 plus 42 would be 246. And then we just multiply 246 and 14, which is 3,444. So the sum of those 28 terms, where the first term was 42, and the last term was 204, and we're adding up 28 terms, the sum of those 28 numbers is 3,444. So this is a variation on something that you have to do extra work. You have to use the arithmetic series formula, and you have to use the arithmetic sequence formula in order to get all the information you need to find the sum of the series. This next example is one that gives you a bit of information, but it's got a different piece missing. This time I know A1 and I know AN and I know the common difference. But what did they not give us this time? There's a different piece missing. Let's look at that series formula, and it should just stand out to us. So looking at the formula, I need to know N. I need to know what N is. And that's not given. I know that A1 is 132. I know that AN is 52. And I know my common difference. But I don't know what N is. So I'm going to go ahead and start by subbing in the things that I know. I don't know N. Something over 2. A1 is 132. AN is 52. But I can't go any further with this until I know how many numbers I'm adding up. So we have to know the first number we're adding, the last number we're adding, and how many numbers we are adding. So in order to get the missing information, go back again to the arithmetic sequence formula. So if you take a look at this, if AN is 52, A1 is 132, the common difference is -4, we can use this information to solve for N. And now we see why that was so important last week. So just bring down the 52, bring down 132, we're going to distribute the -4. So I get plus -4N. -4 times -1 is +4. I'm going to put my -4N in the front, and 132 plus 4 combine to be 136. So now I'm just solving this equation, trying to get the N alone, so I'm going to subtract 136 on both sides. I got -4N on the right, and 52 minus 136 is -84. And last, we divide by -4. And it's 21. Now here's something you need to think about. Can I add up a negative amount of numbers? Can I add up a decimal amount of numbers? Can I add up a fractional amount of numbers? When I'm counting how many numbers I'm adding, N, which represents how many numbers I'm adding, has to be some sort of a counting number. It has to be a positive number, has to be a whole number, and it can't be 0. So you have to be a number, it has to be a positive number of numbers that you're adding. So when you're solving for N, you need to get a positive integer. Okay, so N is 21. I'm going to put that back in here. So I'm adding up a list of 21 numbers. So 21 divided by 2 is 10.5. 132 plus 52 is 184. And multiply that by 10.5, and we get the sum of those 21 numbers has to be 1932. So 1,932.
So we've learned a little bit from the video so far. I know we only got 3 examples. We're on example 4 now, but I think at this point we've done enough and we need to stop and do some practice. So we will leave example 4 to another day. I want to remind you, your learning target today is I can find the sum of a finite arithmetic series using the formula. The formula again is Sn equals n over 2 times the quantity A1 plus AN. You get to use your formula sheet when you take an EOC, so don't worry about the memorization of that, but you'll use it so much you probably will memorize it. Best of luck to you, and I'll see you in class.